Okay, today, this is called factored form to general form. So if you do this process of multiplying something out, that was taking vertex form. You remember how the vertex in this is found here and here? The vertex would not be 2 comma 3, it'd be negative 2 comma 3. Does that ring a bell? Okay, and you're taking that, you're multiplying it all the way out. Notice that had to be done first. And then at the very end, you add the 4 plus the 3, making the 7. All right, so that's just basically multiplying it out. And what do we get? General form. So to get general form, generally you just multiply it out. Okay, well, it's the same thing with factored form. That's the point for today, is factored form to general form. You're going to have things that are in factored form, like this. See, it's in factored form. To get that into general form, you just multiply it out, and you'll have general form. Go ahead, multiply that out. Take A there, and multiply it out for me. First outside, inside last. Should be easy peasy. Turn it my way when you're done. I'm going to pause for a second while I gather those answers. 3x squared plus 7x minus 6. Now, it is the best if you have that, say, equals 0, because technically this is not an equation if I just write plus 7x minus 6. That's not an equation. If I say equals 0, that's an equation because it's got an equal side and something on both sides of it. Okay, otherwise this is just called an expression if it doesn't have an equal sign after it. All right, so take a look at this. If that little graph is given to you, there's only one important place to look. Where it touches the x-axis, there and there. Those things are called 4 things. I'd like you to write down the 4 things they are called. I'll tell you, they're -1 and 4. But what are they? Oh, for Pete's sakes, it's written right in that question. I'm sorry. I didn't make this smartboard, so I didn't see that. The roots, the zeros, the solutions, and the x-intercepts. Okay, so when it's in factored form like this, it's so easy to get the answers. You just figure out what makes that 0. -3 does. And what makes this 0, and I'm going to make a classic mistake on purpose. Oh, 2/3. Actually, that worked. 3/2. People get them upside down a lot, or they get them negative when they should be positive. Okay, and that's not right, because what you should do on this kind, I'm telling you, remember, your tests are graded Marzano style, so that means every extra point you get wrong costs you a whole grade. So you go 3x minus 2 equals 0, 3x equals 2, x equals 2/3. And remember, you get 1 free mistake on the front side, 1 free mistake on the back side, but after that, every extra point counts, and all you have to do is forget a negative, and it's wrong. Okay, so be careful. This one came out to positive 2/3. So I got 2 answers, positive 2/3 and -3 are my roots on that. Do you get all of that? That's the review and the new stuff. How could that have been the new stuff? Because the new stuff was, how do you change factored form to general form? There it is. It's in factored form. How did you change it to general form? Generally, you just what? Multiply it out. That's it. All right, so I'm not going to take a lot of time on this. I am going to talk about a few interesting things about quadratics. Is it possible to have a quadratic with only one root? Yeah, if it only touches once. We call it a double root. So this one's touching at -4. How could that be? Isn't there normally 2 sets of parentheses? How could there be 2 sets of parentheses that both have an answer of -4? Well, it would be like this: x plus 4 and x plus 4. You get how that's got 2 answers, kinda, but it's really only 1 answer, really? Okay, so it's -4 and -4. Well, the answer is -4. So if you ever have one like this, where it's the exact same thing, could you put them together and say x plus 4 squared? Like this? Could you? Yes. And whenever you have one like that, do you get that it must be touching the x-axis? It must be bouncing like that. Now, it could be bouncing from the other way. All right, I don't need you to make tons of connections here, I mean, it's great to make connections, but I don't want to linger on it forever to try to get you to make advanced connections. General form, vertex form, factored form. Do you get, this is the one you haven't really messed with very much. I know you've seen a million ones like that, and we've done a lot of factoring, so this is kind of the new one for you. If so, what's the vertex on that thing? Use H and K, but write it carefully. What's the vertex on this equation right here? The most common mistake answer would be negative H comma K. Why is it not that? Who could explain why? Yes? Because it's in the inside, and therefore, what's the deal about the inside? It's always the opposite of what you think. Yep. All right, good. All right. So this is in factored form. Basically, if you can factor something, you've got it in factored form. All right. I've been doing this on the top 20s forever. Let's see if you can factor something for me. We'll set it up like this. 0 equals 2x squared plus x 15x plus 7. There we go. Factor that one. Do you get I just gave you general form? It's already all multiplied out. What I'm asking you to do is to factor it, and then you'll have factored form. Two x and x is how you start. Now somebody talk me through this. Act like I'm your little brother who's in 6th grade and he doesn't get factoring. Who can explain how do you get this thing to finish? The 2x and x isn't very hard, but how do I finish it? Come on, somebody step up. Yes, sir. Okay. I'm asking how to factor this. How do I factor this? How do you know it's plus 1? You test it. How can you tell it's, I can't even test it if I don't have it done. So explain it to me. I'm your little brother. I don't understand this. I know I'm the math teacher, but act like I'm your little brother. I don't get, what do you mean plus 1? How do I pick a 1 there? Yes?
You have to find something that multiplies to the plus 7 and something that adds.
So you're saying these two numbers multiply to 7 and add to 15? Something that multiplies to 7. Well, there's only two things that multiply to 7, 1 and 7. But did you say that these are going to multiply to 15? What do you mean the 1 and 7 multiply to 15?
When you go through the outside.
Oh, the outsides give you the middle. So that should make 15. That doesn't make 15. That makes 14. So this is the 14 and this is the 1. Oh, okay, that makes 15. Okay, I get it now. Thank you. All right. So, am I done with this problem? Well, it's in factored form. Yes, I'm done with the problem. Unless they said to find the what? 4 words. Zeros, or the x-intercepts, or the roots, or the solutions. Okay, good. If they said find the solutions, all you'd have to do from here is say, okay, x plus 7 has to equal 0, so x equals negative 7. And this one I better do out. 2x plus 1 equals 0. 2x equals negative 1. X equals negative 1/2. There we go, and there we go. Those are the solutions. Okay, you get this? Just factoring, and then using the factors to get the answers. Did you do this in the top 20? Yes, you did. And that's why this probably seems like yawn easy to you. A lot of kids are going to be struggling right now because they don't know how to do that yet. All right, given a quadratic equation with the following information, write the equation in factored form and then in general form. All right, now this is important. I'm going to go back for just a second here. Do you get that there was no number that we factored all the way to the front? If we had, that would be called a scale factor. So I'm just going to, for a second, imagine that this had been a 4x squared, this had been a 30x, and this had been a 14. Then, when I started, I would have factored out a 2, and then I would have had 2x squared plus 15x plus 7, and then I would have factored it to this with a 2 in the front. Do you get how that's a scale factor? It makes it stretch. Remember that word? Stretch factor of 2. Is it a vertical stretch or a horizontal stretch? It's on the outside. Vertical stretch. Okay, good. So, now, given that, for number 1, write me an equation. It's got a scale factor of 1 or a stretch factor of 1. It would be the same thing. Its x-intercepts are those. Those are the answers. Those are the roots. Those are the zeros. Write me the equation for it. I'll give you a hint. Writing it in factored form is the easy way. Yes, yes, yes. Yep, yep. Except it isn't an equation quite yet. Yes, I can accept that one. Yes. That's in vertex form. It might even be right, but in vertex form, but I don't think it's even right. I think it's not. You need 2 sets of parentheses. Okay. Yes. 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 Now you got it. Yes. 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 Can you make it a little brighter? It's hard to see from the back row. Yours is okay. A little brighter would be good, but I could see it. Good. And now, yes, good. Yes, and yours is even multiplied all the way out. Now, do you have to finish multiplying it all the way out? Well, yeah, I told you to write it in factored form first, and it goes like this. Y equals, or some of you were even smart enough to write it with the 0 equals. Either way is okay. Do you get that a y can be changed to 0 if you're trying to find the x-intercepts? Then y could be 0. All right, if you wrote it this way, technically, it's not quite right. Because if these are the x-intercepts, then we should have set y equal to 0. Okay? All right, there we go. There's a good equation. Now, this one's pretty much the same idea, except this has a scale factor of 3. Go ahead and write it. It should be easy peasy. This time I'm not going to have you check with me. I'm going to ask you to show somebody else in a moment. Try to catch them on any little thing. You don't have to multiply this puppy all the way out. I know the directions say to get it to general form, but I know you know how to multiply. So don't do the general form yet. It'll be a lot easier to compare factored form with your neighbor. All right. We're going to do different rows this time, just to shake it up. Okay? This time, your 2 rows are going to show each other. Your 2 rows are going to show each other. And you're going to show, in this row, you're going to show the person in front or behind you. Okay? So you two, and actually you 3 make the person in the back involved too. And it's going to be you 3 in the back and you 2 in the front. Okay? Show, compare, see if there's exactly the same as yours. Now, some of you guys could be exactly the same and wrong, right? So let's just make sure. Check with one other person now. Make sure that yours is the same as theirs. Also, then that'll increase your probabilities a lot. All right, I'm hoping you had 0 equals. How many had that right this time? Okay, good. And then the scale factor is 3, and then you just make 2 sets of parentheses, and I hope you did x minus 2 and x minus 5. There we go. Okay, now could you multiply this all the way out? Yes. And if you had to, this would be the part you would multiply out first, and then you'd multiply everything by 3. Please do that. Multiply it all the way out, get general form. And then you're going to compare with those same people you compared with last time. Don't show them until they're done. pause for a second here. All right, so what did you get? We're going to go over here in the corner. Mrs. OR. 3x squared minus 21x plus 30, did you say? Raise your hand if you had the same thing. Okay, good. And you hadn't quite finished. I'm sorry. Finish. Equals 0. I'm going to put that over here just for constraints on space. Yes, otherwise it's not an equation. All right, good. That is called going from factored form to general form, and generally you just multiply it out. All right. I think the axis of symmetry is the hardest part of this whole lesson, and let's do that now. So get to the yellow picture. Now, if we know these are the two answers, -2 and -6, then would you put dots on there, please, at -2 and -6? And if I know it's a right side up parabola, I know generally it looks something like this. But we're going to ask you to be more specific than just be general like that. Okay? Generally it looks like that, but where exactly is this vertex? Where exactly is it? Well, would you agree that it has to be, since there's symmetry on these parabolas, that it has to be on the line that runs right between those two dots? Does that make sense to you? The vertex has to be on that line, doesn't it? Now, exactly where on that line is it? You can do this in multiple ways, but there's a slow way and there's a fast way. Would you agree that this is the line x equals 4? -4, sorry. Would you agree that's the x equals -4? Then, if I tell you x is -4, can't you just stick it in the equation and find something important? If I know x is 4, can't I just stick it right here? Or -4? Yeah, I can. Let's do it. What's -4 plus 2? -2. And what's -4 plus 6? +2. And what do they get when I multiply them? -4. And bring down this y equals all the way, and you'll see, oh, I guess y is -4. It tells you where the vertex must be. Go down 4. 1, 2, 3, 4. It must be right there. That's where the vertex is, the most important point in the parabola. Did you get that? All right, so the vertex is at -4, -4. And the axis of symmetry is that dotted line that runs right down the middle of them. Right there, x equals 4. And one more thing, the y-intercept, fill in that sentence I said before. The y-intercept is where what? Come on, the y-intercept is where what? X equals 0, good. Then, if x equals 0, can I just stick that in the equation? Yeah, 0 and 0. 2 times 6, which makes what? 12. So I figured out that y equals 12. That seems important. What is it? It's the y-intercept. It's where x equals 0. You just stick a 0 into your equation. Y equals 0 plus 2 times 0 plus 6, which makes 12. So y is 12, and y is 12 is the y-intercept. So if I was going to graph it, it would be like up here. So now I can make a much more accurate parabola. All right, and all you really needed to do that is to know where it touches those roots, those zeros. You know how those are so important? They have 4 names, the roots, the zeros, solutions. Okay, so on this one, go to the blue screen, and this one summarizes everything you have to know for today's homework. First of all, you got to write it in general form. Generally, you just multiply it out. But remember to do that first. It's way easier. And then multiply everything by -2. Go ahead and do that. when I FOIL it out, get x squared minus 7x plus 10. And then I times everything by negative 2. And I get negative 2x squared plus 14x minus 20. Agreed? I'm seeing lots of nodding heads. Good. Now find the x-intercepts. That's easier to go back to this original thing and find them up there, isn't it? I can just do them really quick in my head. It's 2 and 5. So now I'm going to graph it. It goes through 2, and it goes through 5. Now we did this one on purpose because the line that runs right through the middle of them isn't quite as nice this time. It's not impossible, but it runs between the 2 points. Those special spots where the 2 lines cross, you know, like here or here, that would have been really nice. Those are called lattice points, by the way. This is not falling on a lattice point. It's running right down the middle. And by the way, if you don't want to like count it out, you can just average the 2 and the 5, and it'll tell you where to put that line. Average 2 and 5. That means add them together, divide by 2. 2 and 5 adds up to 7. Divided by 2 is 3.5. So I know that that line is at 3.5. I'm going to use 3.5. So now, I'm going to make a classic mistake. I'm going to say, okay, well, I know that the vertex is down here on that line. Not true. What about this equation tells me it's not down there? The negative. The negative in the equation tells you what? It's been flipped upside down. That negative tells you it's an upside down parabola. It's not going to have a dot down there. Its vertex is up here so that it can be upside down like this. Okay, now exactly where is that spot? I told you a good way to do it. We know x is 3.5. What do? Plug it in. Plug in 3.5. Plug it in here and here. So 3.5 minus 2 is 1.5. No, it's not. 2. Was that right? Sorry. 1.5. I had a brain block for a second there. Okay, so that one's 1.5. 3.5 minus 5 is minus 1.5. Did you notice that happened the last time too? We had 2 and negative 2. You're going to see that happen a lot on these. Or if you figure out one of them's like 6, the other one will be negative 6. All right, so anyway, you'll catch on to that. Then this 1.5 times this, negative 1.5, times this, negative 2, will give me the answer. And, wait a minute, I already have my x-intercepts, and x-intercepts are at 2, x equals 2, and x equals 5. And since they're x-intercepts, I should really put them as 2, 0, and 5, 0. That makes them into points. Okay, find the vertex. That's the part I'm working on right now. I got to finish this job. I know that I'm supposed to stick in this 3.5 into this equation, and now I have to multiply this nasty thing. All right. Ooh, multiplying 2 times 1.5 actually makes it better. 2 times 1.5 is actually 3. So this becomes negative 3. So it's negative 3 times negative 1.5. So it's really 3 times 1.5. Now, if that's hard for you to do in your head, I understand. The way you do it is you go 3 times the 1 makes 3. And 3 times the 0.5. What's half of 3? 1.5. So 3 times the 1 made 3. Plus 3 times the 0.5 makes 1.5. Total is 4.5. All right. Nasty that they had to throw in a decimal, but they did. And how did I handle it? I stuck it in there and worked it out. And it wasn't super nice and easy, but I got the decimals and I knew I had to multiply them at the end. If you don't have a strategy for multiplication, that's really sad. You're in an honors class, and if you can't seriously multiply, that's a bad thing. You need to know how to multiply. That's one of those things that I actually do spend time on because I know in your heart of hearts, a lot of you know that if I gave you two complicated numbers, you might not know how to multiply them. Because, unfortunately, you got confused in your childhood because we now teach two different ways to multiply, and some of you get them mixed together, so you don't know really how to multiply anymore. So if you are scared that if I gave you 4.5 times 9.6 and you know you probably couldn't get the answer right, then don't worry. You're normal for Minnetonka, sadly, because we've got two different systems. A lot of kids don't remember either one of them well. So we'll spend time on that later to make sure you got a strategy you can always pull out. I know that technology is a big part of your life and always will be, but so it's not likely somebody's going to corner you in the office at your work and say, here, multiply these two numbers. And if you can't, you'll be shunned. It's not likely that's going to happen because you've got a calculator. But you still need to know how to multiply. It's kind of an important math skill. All right. We'll do a little test on that later and see who knows how to multiply and who doesn't. And if you don't, I'll fix it. All right. So what did we just figure out? We figured out that the point was at 3.5 for this, 3.5, comma, here's where we figured out the final answer, 4.5. So 3.5 comma 4.5 is where this is. So I'm going to go over 1, 2, 3.5 and up 1, 2, 3, 4.5, and it's like right in the middle of that place where I wrote that. So I'll just move it down here. And I'll go 1, 2, 3, 4.5. It's right there. So there's my vertex. So I know my parabola goes like that. All right. So that started with the topic is kind of misleading because the topic for the day was factored form to general form. And yet the hard part of today's is that stuff where they give you these two dots and you have to figure out where the vertex must be. All right. The last thing is find the y-intercept. That's easy if you remember what I told you before. Fill in the sentence. The y-intercept is where what? X equals 0. So I just stick in a 0 here and a 0 here, and that's the easiest part of the homework, no doubt. Finding the y-intercept should be your happy place. So this is negative 2 times negative 5, which makes positive 10. 10 times negative 2 makes negative 20. And if I'm going to make it a y-intercept, it's where x equals 0, right? So 0 comma negative 20. Okay. So this is just like a side note here. You can get the vertex of a graph using the quadratic formula. And basically, the thing I'd want you to get out of this is the vertex is found at negative b over 2a. That is a really handy thing for finding the vertex. Negative b over 2a. But you need general form to do that so that you'll have a and b and c. So it'd be 1 and negative 6 and 5 are my a, b, and my c. And then the vertex part of it is right here, negative b over 2a. Notice that's in the quadratic formula. It's this part right here. And why would that part get alone in the formula? If you made this part equal 0, it would disappear. So on those problems, to find the vertex, if we get rid of this part of the quadratic formula, negative b over 2a tells you the vertex. Okay, let's move on. I think I want to just give you one last little quiz here. Here is a simple one. You should be able to tell me vertex form for this thing by finding the vertex. And notice this puppy's been stretched because it's not just over 1, up 1. I hope you notice that it's been stretched. Okay, find vertex form by just knowing what the vertex is. All right, me the equation for that. Find factored form. Put it over here. And if you've got both of those, noticing there's a stretch involved, then you totally get what we needed you to know for today. Okay, vertex form. Do you get the vertex is just buried in this thing? And the vertex goes here and here. So if the vertex on this puppy is -1 comma -2, then I just have to put a -1 and a -2 there and there, and I'm close. What did I do wrong? Classic mistake, yes? Make this a plus because it's always the opposite of what you'd expect. So y equals 1, or x plus 1 squared minus 2. That way my vertex right here matches up with the vertex I know is true. Raise your hand if you had that right. Okay, good. Now this next one, the factored form. To do factored form, we look at these guys, 0 and -2. So how am I going to write an equation that involves 0 and -2 in my factors? Well, here's the classic mistake. Okay, what's wrong with that? Yes? You're right, and I'm going to go back and fix it in a moment, but just hold on. Let's do the, it's not a sorry thing. That's a good thing that you noticed that. Let's finish this one, and let me talk about this the stretch factor, which I'll throw in at the end. Okay, so what mistake am I making on this one? Because I think I should use 0 and -2. Why am I doing it wrong slightly? Yes? So plus 0 and -0, really, it doesn't matter much, right? But it should be x plus 2, yes. That way, this -2 right here makes that part equal 0. Another way to say it is, it's just the opposite of what you'd expect. All right, now, what did I forget in both equations that's really important and so easy to forget? And I even mentioned at the beginning, the stretch. If I didn't have that stretch factor of 2, see, normally it should go over 1 and up 1. It should be right there. And instead, it's actually twice that high up here. It's got a stretch factor of 2 that needs to go there and there. All right, very easy to forget that stretch factor. I did, to be honest. On that first one, I wasn't like trying to test you. I usually tell you ahead of time if I'm making a mistake on purpose to show you it, but this one I just forgot. So anyway, there's a 2. There's a 2. Now I got my stretch factor in both of them. And one more thing that's easy to forget, if this parabola had been upside down, what would we need to throw in? A negative. All right, good. All right, you know everything you need to know. I am going to cut your homework down a bit because today's lesson was significantly longer than I thought it was going to be because I forgot we were going to be including that part where you have to do the dotted line down the middle. Those problems add a lot of challenge. So, all right, that's the end of lesson